Hey Blake, how are you doing? It is the start of another week. Got lots of office hours this week. How are you doing? It is Halloween. Oh my gosh, gotta play like some spooky music. Do we have any spooky music? That's not spooky. I don't know if I have spooky music. Halloween music, right? Roshni, good to see you. I'm trying to find spooky music. Is there a spooky Brian? I couldn't figure out. Spooky day today. Trying to find. I don't have enough spooky music. Wait, let me go to the YouTube free library. We'll do that. But how's everyone doing? It's time to do some work. I'm trying to get Canvas and my Pearson are having troubles. Oh my gosh. I just can't get the two to work. Let's find spooky. So Halloween. Frightmare. Should download this and play this at the start of office hours or start of class. Do you like orange Kit Kats? Kit Kat's pretty good. I like Twix. Sinister. Need like a evil laugh or something. They're amazing. I have to try them. Pretty good beat. What do you think? First, second, or third? We should play one at the start of class. I'll appear to it. Be like.
Maybe I'll do when the beat drops. The first one was spooky. Okay.
Let me get that one downloaded here. You can play these. Wait, is it like no attribution? License type. You can use this track, including your videos that you monetize. No attribution is required. Okay. YouTube may credit the artist. Okay, good. Okay, no attribution is required. Some of them you have to go and like add the attribution afterwards. And I'm like, I mean, if YouTube attributes it, I don't care. They can attribute things in my, perfectly fine. Let's take off mystery. I've never liked mystery. Okay. There we go. Okay, I've got it now. Let me change the thing to Frightmare. Why is it all the crazy text? Decrease font size. Halloween. Okay, here we go. We almost got it. Okay. There it is. Chapter 12, you bet, Wes. We're getting some music going here. Some
Halloween music.
Start class with this. Here we go. Let's get chapter 12 up and going. I got a fair one to drop in. Ma Pearson, which chapter 12 thing should we do? Let me see. It's not too loud, is it? Very important. Good. Trying to get my Pearson re-sync. I'm gonna put on chill music while we do this. There we go. My chill music. A certain bowler. Ooh, I don't know if I've done this one. A certain bowler. Okay, we're getting up and going here. A certain bowler. I emailed my Pearson again. There's a problem with the syncing of assignments. It's been doing it for just like the last week or two. So I've been trying my hardest to get them to sync properly. I've been speaking to their tech support. We'll get it figured out probably this week. I don't know, like you never, like it's like I'm trying to get done. Is this homework or quiz, Wes? Homework or quiz? Can we do the Canvas content quiz? We'll do the Canvas content quiz. We'll do Wes's question first, and then Roshni, do you want to do the Canvas content quiz? And Wes, is yours homework or quiz? I'm going to the quiz. Oh my gosh. Certain bowler. We are About ready. It's quiz? Okay. It's okay. It's quiz. Certain boulder. Certain boulder. And let's do some canvas content. Which canvas content is it? Is it over decision trees or which one? A nervous kicker. Oh, please don't tell me there's different versions of these. They like change the wording of it sometimes. Certain boulder. The Mars Candy Company. My Pearson, do you have a thing? A certain bowler. Found it. Decision tree one. Cool. Okay, let's put that on the map right here. Stat 201. Stat 201. Chapter 12. Quiz. Certain bowler. And then Stat 201. Canvas content. Decision trees. Okay, let's go check this out. Here we go with the certain bowler. Let's do it. Okay, so this is the quiz question right here. Now this goes over the rules of probability, so we have to know the rules. So have your notes out and we'll be in class today. Oh, no worries. Congratulations on the tournament. Yeah, it'll be Taylor. Let's throw Taylor some points. We haven't even given him Mubot points today. Taylor, good luck on the tournament. You'll do great. And remember, class is recorded. Remember to ask any of those questions. Thank you, Taylor. Have a great day and enjoy the tournament. Good luck. Ooh, soccer. I was never good at soccer. It's one of the any sport that requires coordination or a ball, not good at. Brian was cross-country track. That's all I did. Ran the 2 mile. 5K, 2 miles. That's all I do. 17:12. 1 mile was like 5:02. Might have thought I was close to 5. Never broke 5. I didn't go to states or anything. That's decent times. Decent times. Here we go. A certain bowler can get a bowler strike 85% of the time. Now, here's the thing that it's wondering. We're talking about sports right here. I should wear my sports shirt today. Go Vols. This is assuming each time they throw the ball, the previous throw and the current throw are what of each other. This is assuming each time the bowler throws the ball, each throw would be what of each other. What do you have to assume? You may not know this. You can say I don't know in the chat if you want. But what do you have to assume if you're going to look at 3 consecutive strikes? Because it says the probability of strike is 85%. Independent West, let's throw you 1,000 points. Didn't know if anyone would know that yet. That is true. So when you're looking at multiple events occurring in a row, if you're going to multiply them together, they have to be independent. Now be careful. Learn the difference between independent, disjoint, mutually exclusive. Good to see you here, Taylor. All the Taylors here today. So make sure to learn those differences between the words independent, disjoint, mutually exclusive. Mutually exclusive and disjoint are the same thing. It means if one happens, the other can't. Like I like to say, if your parents get you a dog, you can't also get a cat. I mean, some parents might be cool, but sometimes we have disjoint things where if you get a dog, you can't get a cat. So independent means if one thing happens, it does not influence the probability of the other. So disjoint events are actually very, very dependent because if one event happens, you get a dog, you can't get a cat. It's very dependent. Like getting a dog is dependent on getting a cat. So this assumes independence, which if you get a bunch of strikes, you're probably getting some anxiety. It might be changing it. It should say assume independence. Okay, 3 consecutive strikes. So the probability of a strike, remember these rules and stuff, if one thing happens, the outcome does not affect another. It's boom, Blake right there dropping some definitions. That's the way to think of independence right here. So the word we use for this one is and. So we have probability of strike is equal to 0.85. That's the probability of a strike. So what's the probability of a strike and a strike and a strike? So what's the probability of a strike and a strike and a strike? If you know how to do this and I say it that way, if you've been practicing, don't worry if you don't know. I don't know is a great answer. But if you know how to do this and you hear me say, what's the probability you get a strike and you get a strike and you get a strike? If you know how to use the words, then you will get it right here by me just saying that. When I say the word and, you have to assume they're independent or know they are, like they must be independent. And if I say the word and, what are you going to do? Watch what I'm writing right now. If I say the word and, what are you going to do to probabilities? Like the probability of a strike and a strike and a strike, you're going to what? And equals multiply, Blake. That is correct. Exactly right there. Perfect answers. Keep it up right there. More points in the chat. You're going to multiply those probabilities. So we just go right here and we go 0.85 times 0.85 times 0.85, and we have the answer. So and is when we have independent events and we can multiply them together. It says to the nearest thousandths digit. So thousandths is the third digit. We have tenths, hundredths, thousandths. So it wants it all the way right there. The probability, okay, so this one says makes her first strike in the third frame. Okay, so this one's a bit odd. So in the third frame, well, the third frame is going to be just your third throw, I think they're talking about. So got to be careful. Is it talking about a frame is like, well, no, because if you miss it, okay, yeah, because it'd be the third throw. Okay. So, and only takes effect if it's independent. Correct. We only use multiplication when two things are independent. Correct. Because you say, what's the probability of it being 90 degrees out today and snowing? Well, snow is dependent on temperature, so you can't multiply the probabilities. You say like 2% of the time it snows in Knoxville and 50% of the time it's over 90 degrees, or I don't know, 20%. 20% of the time it's over 90 degrees. What's the probability it's over 90 degrees and snowing? Snow would be dependent on temperature, so the probability is actually zero because it can't snow if it's 90 degrees. So you can multiply two things that are independent, but if they're dependent, like what's the probability it's above 90 degrees and snowing, well, then you think, wait a minute, snow depends on temperature. I can't multiply these. There's interesting ways, like what's the probability if you ace the final, you'll get an A in the class. Getting an A in the class would depend on your grade in the final. Getting an A on the final would actually increase the probability. So you have to think, do these two things influence each other? And this one is assuming, because it doesn't give us any other mathematical way to do it, that each throw is independent. So this one's a bit interesting right here. What's the probability of her making making her first strike in the third frame? So when you look at this right here, you have to watch what happens. When she was doing bowling, what happened in her first frame? So we're looking at the probability of her making a strike in her third frame. What happened in her first frame? First frame being her first throw. What happened in her first frame? What's the probability of her making her strike in her third frame? So what happened in her first frame? So you have to like watch what happens right here. I guess it does take a little bowling knowledge, which is a little unfair, but so what happened in her first frame? Hey, Evan, what's up? We got the duo here. What happened in her first frame? So what's the probability of her making her first strike in her third frame? So for that to occur in her first frame, she would have to do what? So she makes her first strike here. So in her first frame, she would have had to done what? It's like a riddle. She got a sparrow, so she didn't make a strike. Does that make sense? She didn't make a strike. I agree with Wes right there. She didn't get a strike. And in her second frame, she didn't get a strike. So probability of strike, it's like a pro, right? Did they say the probability of strike is 85%? So the probability of a strike is 85%. So we would get here 0.15 times 0.15 times 0.85. So it's the probability of not getting a strike, not getting a strike, getting a strike. Does that make sense right there? So she didn't get a strike, and then that's the first frame, because just kind of what happens after is just contingent on the not strike. And then the second frame, she didn't get a strike, and then she did. And Victoria, great to see you here. And Keith, good to see you here too. We got everyone here. So we're going to do Canvas content next. Check it out. So 0.15, 0.5, 0.85. That should be the probability right there. Can we? Yeah, I think that's what we're doing next. Yep. And round to the nearest thousandths. So it should round to that right there. And probability of bowling a strike is that. There we go. You are heading to the law. Yeah. Ooh, yeah. That sounds a lot like what we're doing right now. The probability of having at least one strike in the first three frames. Now, this is a really great question. Like this question right here is probably one of the toughest ones because you have to use all the rules of probability, because this right here, at least one strike. Well, this one's a lot easier, even though it sounds really tough. I want us to think about how you have at least one strike. Scenario in her first three frames where she doesn't have at least one strike. In her first three frames, what is the one scenario where she doesn't have at least one strike? So think about, to have at least one strike, the only thing that would not suffice for that is when you have what? So think through that. This is one of the toughest questions on the test right here. Like this one right here. So what would you do if you didn't meet that? So we're trying to find out the probability of at least one strike. So when would you not have at least one strike? Like in what scenario do you not? So you have 3 frames. In what scenario would you not have at least one strike? When you have what? In what scenario would you not have at least one strike? So think about it, I say, do you have at least one ace in your hand? Like you have cards and you're like, do you have at least one ace? And you say no. Then what does that mean about your hand? I say, do you have at least one strike? And you say no, I don't have at least one strike. It would mean what? What scenario would suffice for that? Well, but for bowling, if you don't have at least one strike, she doesn't have a strike. Exactly. She has no strikes. Great job, Roshni, right there. So let's look at how this works here. Remember, you just said she has no strikes. Now, I want to show you why we're solving this. We're talking about bowling. I was using like another way of talking about it because you have to know a little bit about bowling, which hopefully it's like, yeah, I switched it to cards to say like you don't have any aces, you have no strikes. So think about this. She has no strikes. What is the probability of getting not a strike, not a strike, not a strike? Good to see you here, Sarah. Who can tell me the probability? I'm going to write here in a second of not a strike, not a strike, not a strike. What's the probability of not getting 3 strikes in a row? Or, excuse me, getting not a strike 3 times in a row? Be very careful with your knots on this. What's the probability of getting not a strike 3 times in a row? 0.15, exactly, because we're just going to multiply these together. Now, here's where the complement rule comes into play. Would you agree with me? She's either going to get not 3 strikes in a row, or she's not going to get 3 strikes in a row, or something else is going to happen. Like, could it be the case, like something else could be like, she gets a strike here, she gets a strike here. Does that make sense? Like, it must be the case that either, I'll write it out, she has at least one, or she has none. Would you agree with me? She's either going to get at least one strike or no strikes. She's going to have at least one strike or no strike. Does everyone agree to that? Oh, I'll find out here in a moment, Evan, after it. So what would this probability equal? If you add together these probabilities right here, what would they equal? What would those probabilities equal? What would those probabilities right there equal? Because you agree to me, one of those things must occur. So if you add that up, the probability of at least one, that came from probability of strike is 85%. Probability of not a strike is 15%. Well, no. So if you add together, so one of these things, listen to this right here. You ready? One of these things must occur. She will either get at least one strike or no strikes. One of those things must occur. So don't worry about these probabilities right here. That is the probability of getting no strikes, but one of these things must occur. So if one of those things must occur, then the probability of it is what? So listen to the words. It must occur. One of those things must occur. If she bowls 3 frames, she will either get at least one strike or none. So what is the probability if one of those things must occur? Must occur is the key word. They must occur. Well, think about this. Like when you get your grades back, you will either have at least one A or no A's. Does that make sense? To Evan's question, you're going to get your grades at the end of the semester. You will have at least one A or no A's. Does that make, like, one of those things must occur? When you look at your grades, you're either going to have at least one A on your report card or no A's. And I'm saying at least one A. So you have one or more A's or no A's. Does that make sense? So this is the sum of all probabilities must equal to what? If we know everything that could occur. So don't worry about any of the numbers up here. Just think about this. You ready? I'm going to ask it again. If it must occur, like the sun coming up tomorrow, the probability of it is what? If it must occur, the probability would be what? Probabilities range from 0 to 1, 100%, right? So don't worry about any probabilities above. She's either going to get at least one strike or she will get no strikes. One of those things must occur. And these are disjoint because she can't get no strikes and at least one strike. And we're going to be going over this a lot today. These are the tougher questions. So think about this right here. We want to find out the probability of at least one strike. Well, that is the probability of not getting 3 strikes in a row, Evan. That's the probability of not. So, Evan, you just found this right here, but you want to find the probability of at least 1 strike. Do you see the mathematics right there now, Evan? Can you? We're about to do it here soon. Kylie, good question. So, what should we do now? You want to find the probability of at least 1 strike. Evan, you just found the probability right there of no strikes. The probability of no strikes is not a strike, not a strike, not a strike, or not a strike and not a strike and not a strike. And Evan, you're seeing it right there. You're just going to algebra it over. So Evan, great job. This is one of the toughest problems. It requires pretty much all the rules of probability to solve. So the probability of at least 1, we'll abbreviate it that way, is equal to 1 minus none. Does that make sense? And the probability of none, shown up there in the green, the probability of none, Evan solved it out. I'm going to check the work, is 0.0. This is one of the toughest questions, though. And there it is right there. It's the probability. And the probability of at least 1 strike is going to be equal to that. Does that make sense right there? This was one of the toughest problems. So 0.15 times 0.15 times 0.15, the probability of no strikes. 1 minus that is the probability of at least 1 strike. Why does it equal to 1? This right. So think about this, Victoria. If you go to the mall, you will either buy at least 1 video game or no video games. Everyone who goes to the mall will either buy at least 1 video game or no video games. Does that make sense right there, Victoria? We could talk about anybody. My sister goes to the mall. She doesn't play video games. She'll either buy at least 1 video game or no video games. My wife plays video games, goes to the mall. She either buys at least 1 video game or no video games. Now, each person would have their own probabilities, but if you describe something as there will be at least 1 of this or none of this, then one of those things must occur. Like the probability of her getting at least 1 strike or no strikes, one of those things must occur. Yeah, so they're disjoint and they're also called complements. Complements are either A or not A. So you'll either have none or at least 1. So you'll either have none or not none, you could say. Not none means at least 1. And the quickest way to say a complement is not none. So, or not this. Got some fun going on in the chat. That's a really good tough one right there. That is probably some of the toughest the questions get on the test. Round to the nearest thousandths. So this is going to round up. Please, I hope we don't get any round. Complements. So it's either A or not A. Like literally the easiest way to talk about complements is A or not A. So you can just say not this. Like if you're in a family of 3 and there's 3 boys, what's the complement of 3 boys? Hint. I'll give you a hint. Brian's family is in the complement of 3 boys. There's 3 children in my family, and we are in the complement of 3 boys. So, well, if you have 3 boys in a family, what's the complement of 3 boys? So use the trick right there I just did. What's the complement of 3 boys? My family is a family of 3, and I am in the complement of that. Not no boys. Remember, I'm in the complement. That's a hint right there. So your family either has 3 boys or what? What is the complement of having 3 boys? This is one of my checks to make sure, because one of the quick answers right there is no boys, Blake, right there. So your family either has 3 boys or what? Remember, I'm in a complement family of 3 boys. So, and I'm a boy. So your family either has 3 boys or what? What is the complement of having 3 boys? Because you either have 3 boys or use the word right there. Kind of, but think about this. Just use the one word. There's one 3-letter word you can throw before it, and then you'd be like, oh, because you either have 3 boys or your family does not have 3 boys. Does that make sense? So my family has boy, boy, girl. So you either have 3 boys or you do not have 3 boys. Does that make sense? So it's not all girls. That's kind of a totally different, like not getting 3 strikes and getting 3 strikes are not complements because you could have other things that occur. You either get 3 strikes or you do not get 3 strikes. Does that make sense? What is the complement of getting 3 strikes in a row? This is the last question I'll ask on this. So think about this. You either get 3 strikes or you do not get 3 strikes. What's the probability with this mathematics right here of getting 3 strikes, which I don't think is the last one. And then we'll do perfect game. What's the probability of 3 strikes? First off, what's the probability of 3 strikes? Because she'll either get 3 strikes. I wish it did not perfect game. So what's the probability of 3 strikes? So use this question right here is pretty much the whole chapter. Exactly. So what's the probability of not getting 3 strikes? You see how I just put not before it? So if you find the probability of 3 strikes, what's the probability of not getting 3 strikes? Because you'll either get 3 strikes or you won't get 3 strikes. So Blake, right there to that one. If you're following along with this and doing this extra practice, you're learning how to use the complements and learning how to be like, okay, she either gets 3 strikes or she does not get 3 strikes. So what would be the probability of that? Boom, Blake, and perfect right there. Exactly. Blake, great job on the parentheses. Yes, exactly. And that's exactly how you do it. You just say, well, this is the probability of this, not the probability of it is 1 minus it, because you either get 3 strikes or you don't get 3 strikes. And those mathematics you just did right there would add up to 1, because you must either, if you bowl 3 frames, get 3 strikes or not get 3 strikes. So this is the practice for the test. I think sometimes people skip through these parts of the videos, but these are the most important parts. Probability of a perfect game. What must happen if you get a perfect game? What must happen if you get a perfect game? Remember, the probability of a strike is 0.85. So if the probability of a strike is 0.85, what happens if you get a perfect game? And how could we abbreviate that? How could we abbreviate that? Brian gives you 5. I wish. I went bowling a while ago and I got like 6 strikes in a row. I got something ridiculous and I almost broke 200. Oh man, it was like I got like 180 or high 170s or low 180s, but I was like one contingent strike upon it of getting it. So I was really bummed. Like I bowled like 2 strikes and I was like, that's good. And I got a turkey and I was like, that's good. And I got a 4th and I was like, I usually get like 130s, 140s. Like it was a very odd game. I can break 120 most of the time. 120, 130, 140. 140 I'm happy. 150 I'm excited. But I hit like 170 or 180. I should have took a picture of it. So what's the probability of bowling a strike? I was in bowling club in middle school. Only middle school. Didn't make it to the high school team. Yeah, we're going to do canvas content. So what's the probability of getting a strike? But there's 12 frames in bowling. I almost messed this up. Did they tell you that? 12. Okay, yeah, they did. They have to tell you that. So the perfect game would be 12 strikes in a row. Glad they tell you there's 12 frames. Wes is, were you actually? You used to bowl in a league, Wes? That's cool. I bet if you bowled in a league, Wes, you probably broke 200, right, Wes? Like I was just in bowling club or whatever. If you bowled in a league, I'm guessing you broke 200. I was cold. Yeah, you broke 200. Yeah. I have a friend who's in Nashville and his parents own a bowling, or they did own a bowling. I don't know if they still do, but his parents owned a bowling alley. And we went bowling. He would just throw strikes down. And we were like, dude, you bowled a strike. And he's like, eh. And he's like, I bowl all the time. He wasn't being like, he's just like, whatever. No, there it is right there. There's the probability of the perfect game. Just throw it into Google or whatever probability it gives you, raise it to the 12th power, and that will be it right there. Does that make sense? Because it's 0.85 times 0.85 times 0.85, but don't do it the long way. Just abbreviate it as 0.85 to the 12th power, because it's probability of a strike and 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 a strike. So even if you can bowl strikes 85% of the time, you'd only get a perfect game about 1 in 8 times or 1 in 7 times. That's very close to a 7th. That's very close to a 7th. But that is the probability of a perfect game. We should have everything correct. We're gonna do some canvas content here. But this question, let's hope we rounded everything correctly. Oh, what did we not round? What did we not round? Rounded that one. That one looked a little odd to me. Rounded that one. Where did we not round? Really? The first one, 3 consecutive frames. Wait, what is the probability? Resolve the first one. What is the probability of her going 3 consecutive frames without a strike? What is the probability of her going 3 consecutive frames without a strike? Not with a strike. Not strike. What is the probability of her going 3 consecutive frames without a strike? Not a strike. Exactly. Great job right there, Blake and Evan. I was just seeing people following along. Not a strike. Whoops, got to punch in correctly. Not a strike. Oh my God. Not a strike. There we go. And there it is right there. And these two right here, here's a good check for you. Do you notice how these two are complements? Because she'll either get not 3 strikes or she will have at least 1 strike. So they give you the complements right here. Notice right here, and thank you so much, Blake. And I think if you already hidden the user on the channel, Blake right here, we're throwing you 5,000 points. I blinked and Blake did some great moderator work. Thank you so much, Blake, right there. 5,000 points. I appreciate that. That's why we have mods every once in a while. Blake right there. I blink and Blake does the work we need done. We appreciate that so much, Blake. You rock right there. 5,000 points for doing the mod work. The reason Brian has mods. So thank you so much. Let's do some Canvas content. Yeah, that is right there. That is people are like, why do you have mods? And I'm like, it's the internet. We sometimes have to throw the mod powers on. So we've got spammers. We've had spammers and trolls before. And this is on the Canvas content, right? It's Canvas content number 5 for you? Or like question 5? Let's knock out this Canvas content. I was just seeing people following along right there. I was giving you all the really tough questions. Man. Oh, I can't believe I read that wrong. Little tiny text right there. Let's go to the Canvas content. That was a really good question, Wes. That was literally had pretty much the full chapter. That was the full chapter. Probably gonna do a lot of this Canvas content right here. All right. We're gonna do multiple versions. Yeah, it was a tough one. It's just being able to draw it out and go through the probabilities, know the multiplication rule, the complement rule, the addition rule. That's we just kind of talked through the full chapter. If you know when you add rules, probabilities need to be disjoint, and you learn how to use Excel so I can run programs. Yeah, Excel's great to learn. R, Jump, SAS, so many great things to learn. Really great stuff. Let me get the timestamp on here. If you learned VBA, Visual Basic, you are a pro. Let's jump over to it. Let's do it. What is the record for points? We might be saying it this semester because we keep having, we need to drop, we'll drop 20K if we beat, we're going to drop 10K for Kentucky today, but we'll probably drop like 20K when we beat Georgia. Stop saying things. A decision tree was made to analyze the characteristics of Stat 201 students who use refillable water bottles. What % of females use reusable water bottles? So is females an X or a Y? Is the females an X or Y variable in this decision tree? Thank you, Evan and Blake. Is the females an X or Y? I am predicting... There it is. There it is. Females are an X. So how many leaves are there in this tree? How many leaves are there in this tree? Leaves are the terminal ends of a tree. This is a leaf report. There's 4 leaves. We're just getting an understanding. And so females are in leaf what and what? Females are in leaf 1 and what? Well, I said 1. So females are in leaf what and what? Which leaves are 1 and 2? Does that make sense? If you just go here and you say leaf 1, leaf 2, leaf 3, leaf 4. So females are in leaf 1 and leaf 2. It looks like the people most likely to use a refillable water bottle would be females who have not broken a bone. The people least likely looks to be males who are 20 or older. Does that make sense? It says they are male, age 20 or older. So let's go ahead and take a screenshot of this, bring it over to Word, talk about how to solve this. So, well, it's just what % of females use a reusable water bottle. Okay. Here we go. Okay. So females are in leaf 1 and 2. How many females are there? How would you know how many females there are? First thing I want you to do is find out how many females there are. And this is a hint the way I'm drawing this. How many females are there? How many females are there? Great job, Blake, right there. That's exactly it. Notice what Blake is doing in the chat right there. Blake is simply taking and adding up all the numbers. Great job, everyone right there. Man, we've got some people just following along. And this is, you just want to understand what's being displayed to you. So if you understand how to read the displays, you can understand that that is saying leaf 1 is individuals who are female who have broken a bone. Leaf 2 is individuals who are female who have not broken a bone. To find out how many females there are, 46 plus 150. We're just adding all the numbers I've highlighted in yellow right there, trying to color code it to help out. And there's 450, 461. Ooh, Mom, what is wrong with Brian's typing skills today? It is 461. We got to give some points for Brian being wrong. There we go. That's why I have you follow along, because I make errors. Then we have right here, what percent of females use a reusable water bottle? I'll give you a hint right here, because that is the answer to the why question. So what would go up here? Up top will be what? Because those are the females who use a reusable water bottle. Oh, I'm wrong all the time, it seems, these days. So, just kidding. What right there? That looks, yeah, that's 326, isn't it? There we go. Because that's the answer to the why question. What's up here is the why, and let's label that. These are your X's. This is your Y. So the X's are things like female, male, broken bone, and age. So now we go right here, and there you go. There's the answer. Here's going crazy. So 150 plus 176 divided by 461. There it is right there. 70.7. It just talks about broken bone. How do we know if it doesn't talk about reusable water though? It says the Y variable of interest. I'll show you right here again. So that right there is always the Y variable of interest. So do you see where it says the response variable Y right here? So this is always the Y. Whatever's right here is the Y. That's what a lot of people, reading this might not see. It doesn't put. I wish it put reusable water bottle right there. I really wish it did. But these are the X's over here, and that's where the Y is. So whatever the no and the yes is right here is for the Y variable of interest when we do a categorical decision tree. So, and great questions. Keep up those questions. That's a very common, like, wait, where's the Y variable? Well, it's the response right there. So really good stuff. 2 decimal points. Should be right. Which split is the most important in creating a tree? It's kind of like when you leave your house. If you drive up to New York, what is the most important turn? You're like, okay, wait, do I go north or south on this highway? You're going to drive up to New York, and you're like, do I go north or south? It says go on this highway for 500 miles. So this is going to be very important right here. You're going to get to Florida and New York. So the first split is the most important in the tree. It kind of determines the rest of the path of the tree. Every split is of certain importance, but the first split is usually 99% of the time the most important. It determines the pathway of the tree. The blank is a list, a collection of individuals from which the sample is drawn. Don't look at the terms right there. These are all things we have access to take. I'm not even looking at the answers. These are all things we have access to sample. These are all things we have access. It's the list of individuals we could possibly sample. So what is that called? The more you know the terms without looking at the screen, the better you are. The sample frame, exactly. So let's do all the definitions right here. Sample frame is the list of things we have access to sample. It's where we could draw our sample from. Sample statistic is like when you try a slice of pizza and you're like, oh, this pizza place is really good. You took a sample and you came to a statistic, a rating, your rating. No worries. Good answers, everyone. The statistic is a part or created from a sample. So if you have a sample, you create statistics from it. If you have a population, you would know the parameter of interest. The population would be all like views of that pizza place, like everybody, like what is the global view? So if you bring 5 of your friends to that pizza place, you will create a statistic from your sample size of 5 friends. You have a 5 friend sample, they come to a rating of the pizza place, which would be a statistic. And if you knew everybody's view on that pizza place, all reviews, exactly. And it's more like if you think globally, it's like everyone who could ever have that pizza, try that pizza place. Does that make sense, Blake? Like it's a nebulous idea because it's often impossible to get a census. You'd have to have like every single person try the pizza place and give a rating. And then the parameter would be the true rating of all people who have had the pizza place. The parameter of interest is almost in flux because more people are trying the pizza place. But if you knew everybody's view of that pizza place, you would know the parameter of interest because that's what you're trying to understand by having people sample it. You have people sample it to infer what the whole population thinks. So it doesn't have parameter on here, but we have to know keywords like that. And this is how test questions look. Like if you're worried about the test because chapter 10 was really crazy hard, this is how the test looks. This is a much better representation. When a sample has characteristics which correspond, there you go. What is that going to be? It is said to be what? Which of these? One of these words we don't even talk about. There's only 2 words right here which really would make sense. I think I look at the answers and every once in a while people pick bifurcated. I don't even know why that's on here. Representative. Representative is what we try to do with samples. Biased is when we're not representative. Biased means we're pulling it in some direction away from the truth. We don't want biased samples right there. And we'll do more versions of these. Jim and Carly are planning on having 2 children. What is the sample size for the experiment? And Jim and Carly are having 2 children. The sample frame, sample frame. Sample space. Oh my gosh. Sample space is the list of all possible outcomes. Using boy and girl right here, what is the sample space with 2 kids? So you have to think what could possibly occur with the boy-girl outcomes. And so we have here the list of possible occurrences. That's 3 kids. That doesn't take account order. And that's just 1 kid right here. Sample space is list of all. Great job, Blake, right there. Getting it right before Brian even can. Yes, and they're planning on having 2. BC. Nice right there. Let's do a few more versions of this right here. 100. Watch me get a question wrong. 100. There we go. Oh, it's in multiply by 100. Oh my gosh. I thought we cleaned up all these ones right here. If you got this wrong, email me and I will fix it. If you got this, my gosh. I thought I went in and have I'm going to go and actively change this right now. Give me a second. I'm going in and literally watch this. I'll even show you the change right here. No one else is going to get caught by that. Okay. It's just this one right here. Look at this. Let's even do this right here. Watch this. You ready for this? Watch this. Now, if you round it up, you're not going to get wrong right there. There we go. No one should be impacted by that now. I think a rock has 0. No ban this question. Can we get the Brian approved sign on the board? Get the approved right there. So now the question has a really there should be no math errors on this question now. So be careful in other sections. They might not have it updated, but the question should have no issues now. It has both answers. I thought we had gone through and fixed every single one of those. I try to catch all those because it really doesn't matter. As the Rock would tell us, it doesn't matter. It doesn't matter if you enter in as percent or decimal. I mean, it just helps us with standardizing answers to do that, but we can enter in multiple answers. So there, you can literally see the answers on the screen right now. So no one else is going to get caught by that. Let's try to do another version of this, and Brian's going to try to get that 10 out of 10. Let's try to do this right here. 10 out of 10s. Let's make it happen. 10 out of 10s. Oh, did we saved it, right? Let me make sure we saved that in there, because sometimes it's so crazy. You have to like go to save question bank. It should be. Let me look. Did you update? Good. It's still there. It's still there. Ban this chapter. Are we just going to ban? How many chapters are we keeping on the test? How many chapters are we going to keep on the test? How many chapters? Should we just do 1 chapter on the test? 0 chapters. The last 3. None. What is the most important split? Remember, these sometimes appear on the test. What is the most important split? Answers all the questions. What is the most important split on a tree? It should be a test on UTK facts. What is UTK's? How many games has UT lost this year? There you go. That's the only question on the test. When doing the decision tree, the split history helps us what? Don't look at the answers. Always remember what a split history is. What does the split history show you? So when you do a tree, the split history is going to do what? What does the split history show you? It's going to show you the history of the splits. And every time you split the tree, you're increasing the splits by 1. So you're going to start here at 1, 2, 3, 4. And then you're going to see, well, kind of, yes. But what do you notice in the split history? The split history shows you the increase in what value, which is the percent of variation explained by y by the x's. So you're going to see the increase in what over time. This is what a split history looks like. The split history is going to show you what? It's the increase in r squared, exactly, which r squared increases the more splits you do. So it's going to show you the increase in r squared, which is the percent of variation y explained by the variation x. So it's going to help us determine how many splits to use. There is no slope in the tree. It does not visually display the tree. We don't use p-values, really. There is a way to do that. Not right here. And there is no y-intercept. So the answers right here that are nonsense are interpret slope. Tree does not have a slope. Tree does not have an intercept. The visual display of the tree is elsewhere, and p-value is not really used, so determine splits via r squared, like to determine where it levels off. So that's how we're going to do it. When you see that like plateau of it, that's generally where you say stop splitting your tree. The purpose of a sample is to have enough data to adequately describe sample statistics. Do we get samples to understand sample statistics? What's the point of taking a sample? Don't even read this answer. What is the point? False. And why? Why do we take samples? To understand, to adequately describe what? To understand a parameter. Exactly. It should say to infer or to understand the parameter of interest. So that would be a population. Like the point of a sample is to understand a population. So we don't take samples to understand sample. We get sample statistics from samples, but the sample statistic is our inferences or lets us infer about a population. Key part of inferential statistics. So exactly. Blake and Evan right there, and Evan and Blake, great job, and keep it up, everybody. These are the points where you want to answer, like just practice your knowledge. Can you go through a consumer organization? Yeah, let's do that one. Yeah, the car one, we like that one. We'll try to do 2 more versions of this. And let's see right here. We did this one. We'll skip through any ones we've done already and talked about. Let's say event A is taking 15 or more minutes to get to work, and event B is taking less than 15 minutes to get to work. Events A and B are said to be complements. A law of large numbers, we'll make sure we get that one. Roshni next. We'll make sure it's in the next version. Then we'll do Wes's question. So what are complements? What are complements? What 3-letter word helps us find complements? We're going to find that one here next. What 3-letter word helps us find complements? Not. So let's try this. You ready? Event A is taking 15 or more minutes to get to work. Okay, get it? Event B is taking less than 15 minutes. So you either take 15 or more minutes to get to work, or can you say not, or you don't take 15, or you do not take 15 or more minutes, which would mean what? If you did not take 15 or more minutes to get to work, what would it be? If you did not take 15 or more minutes to get to work, what would it be? Are you seeing it? Because you either take 15 or more minutes to get to work, you either take 15 or more minutes to get to work, or it would take you what? Well, here, I'll show you it mathematically. You ready? Let's look at it mathematically right here. So mathematically, there's the case that when you go to work, it'll take you greater than or equal to 15 minutes, or it would take you what? If you go to work, are these, and it takes you a time, are these the only 2 amounts of time? Like you could say it either takes me 15 or more minutes to get to work, or it takes me less than 15 minutes to get to work. Well, so wait, did it take you less than 15 minutes to get to work today? And you say no. Well, then, like you arrive at work and someone says, oh, did it take you less than 15 minutes? And you say no. That means it took you greater than or equal to 15 minutes. Does that make sense? This is not the other one. Like not, if we say not right here, greater than or equal to 15 minutes, then it took you less than 15 minutes. Does that make sense? Because it either takes you 15 or more minutes, or it takes you less than 15 minutes. So when it does not take you 15 or more minutes, then it would be the case that it took you less than 15 minutes. Complements are 2 things that describe everything about the world. You can use the word not oftentimes for them, but you have to understand, like if I say to you, I'm trying to think of compliments where it's not that way. The Patriots will either have a perfect season or they will lose some games. Are those compliments? So let me tell you these 2 events again. You ready? Patriots will either have a perfect season or lose some games. Are those 2 things complements? Your team will either have a perfect season or your team will lose some games. Are those complements? And you could say it that way, Blake, right? So are these complements right here? Are these complements of each other? Complement means if they're the total set of they are complements. And you could say your team has a perfect season or does not have a perfect season, but not having a perfect season is losing some games. Does that make sense? So these are complements. You can use the word not, but you're not required to, because there's ways of describing things to say like your team either has a perfect season or your team loses some games, and losing some games is not a perfect season. Does that make sense? If you have a perfect season, you lose no games. So a perfect season being defined as losing no games. Does that make sense here? You don't have to use the word not. It helps sometimes to say like my team either has a perfect season or does not have a perfect season, but you could describe it as my team either has a perfect season or loses some games. These are compliments. So this is a compliment over here because either it is the case that you take 15 or more minutes to get to work, or it takes you less than 15 minutes. One of those things must occur. They're the set of everything. So those are compliments. Let's do that law of large numbers. There we go. There's the 10 out of 10. Let's go to preview. Law of large numbers. We need the law of large numbers one. Hey, here we go. You are heading to the Law of Large Numbers Casino and plan to play their world-famous slot machine. The slot machine at the Law of Large Numbers Casino has 3 wheels that you spin and pull a lever. When pulled, each one stops on the symbols, assuming that each outcome is independent. And if each outcome is independent, what does that mean we can do? If each outcome is independent, what does that mean we can do right here? If each outcome is independent, what does that mean we can do? Very important thing you should know. That means we use the word and if you have things that are independent, so what does that mean? What does which thing mean? The independence? So we have a slot machine and it's got wheels. Good questions right there. And so with the slot machine, what does it mean? So it's got 3 wheels and each wheel is independent. What does it mean that each wheel is independent of each other? What does it mean that each wheel is independent of each other? Each wheel, the outcome of one wheel will not influence the outcome of another wheel. Does that make sense? When these wheels stop, whatever it stops on will not influence the outcome of another wheel. So if the first wheel stops on a circle, the second wheel's outcome is totally independent, that it will not be influenced or changed by the first wheel. So when we think about this right here, we have to know independence means if one outcome occurs, then the other outcomes are not influenced by it. Does that make sense? So independent means if there is an outcome like outcome A, then outcome B is not influenced by outcome A. So if we know the first wheel, it will not impact the second wheel. So the question is for this one, what is the probability you get a lemon, cherry, and a bell? And in that order specifically, like lemon, cherry, and a bell. So when you think about this, what's the probability of getting a lemon on the 10 wheels? What is the probability of getting a lemon? What is the probability of getting a lemon? So use those 3 out of 10. What's the probability of getting a cherry? Great job, Evan, right there. That 3 out of 10. And 2 out of 10 for the next one. What's the probability of getting a bell? Probability of getting a bell is 1 out of 10, right? So if we know that things are independent, independent means, and great job, everyone. Good job following along. Independent means we can what the probabilities we just found. Like if we say, what's the probability of this, and this, and this? Here's the keyword and again from some of the earlier problems. This means we can what those probabilities you just found. Not add, not add. Good question right there. Not add. Add is the rule disjoint, mutually exclusive. So if they're disjoint, mutually exclusive, we can add them. When we do, that is correct, Evan, right there. When they are independent, great job, Charlie, right here. Charlie jumping in and Wes jumping in. Charlie, step 1 all-star right there. We can multiply when they are independent right there because you can think about what's the probability of the strikes that we did earlier from the question Wes had. What's probably getting a strike and a strike and a strike. You multiply the probabilities. So the key words to remember are things like independent. We multiply the probabilities. We can, if we want, to think about independent events occurring. So this would be the probability right here of it. They come back heavy in 471. Exactly. It's false right there. The sample frame. No. That is false. That's the sample space. That's a tricky question. Watch out. That's the sample space. The sample space is all things that could occur. Yeah, this one is not as bad. The probability is a lot of math. When should be avoided. Both of those are kind of wrong. It's got a double period. Who updated this question? I feel like this question's been updated. The how is which one possible? The program will process it. The issue is actually, so the real reason they're avoided is because when you split, and maybe Charlie knows about this a little bit, when you use categorical variables which have lots of levels, the ways in which you can create subsets of splits, like if you have 20 pick two groups, like you have to assign them to two groups, the program will actually heavily split on those variables because there's a lot of ways to divide up 20 groups into two subsets. You're like making group A and group B with 20 items. So when you do that, your trees actually go towards the categorical variables with lots of levels and avoid your other variables, which could cause overfitting or problems with your tree not generalizing to new data because it's going to kind of overfit on the categorical variables and probably be avoided to imply better, clearer interpretations. It says the top one, it says, no, it'll process it. It'll process it. That better not be the answer. That better not be the answer. Yeah, because it'll process it. You can make the tree. I mean, decent stat to 1 reasoning, but I feel like someone changed that answer. I feel like that was updated to, like, the truth is the tree splits towards those, and we don't want it to just pick those variables. Especially if like 100 levels, the tree will just get those variables all the time, because oftentimes the small sample size within a group will create like abilities to. It's just it's a lot of math issues. So Charlie, you've probably seen that. It's a lot of the math going on right there. It's funny. It's like the one of the multiple choice sound like, let's go do Wes's question with just enough time right here, and let's send out the thing to the class. We got some spooky stuff getting ready. Yeah, you don't want to overfit. Yeah, it's gonna especially because it has the ability, if there's so many levels, to take one observation that's weird and subset it off into like the high group. Like if you're splitting by the mean, reducing the sums of squared error, it can like take that one observation, just move it wherever it wants based on that variable, and it's going to overfit with that because there's no, small sample sizes in groups wouldn't give you a good understanding, so it's gonna create problems. It's just a bad idea. Today is a very important day. We got a lot of math work in 201, so make sure to be in class. I'm going to send out the announcement about Watch Class Live. Wes wants the car questions. Those are good questions. Class 19. Oh my gosh. Here we go. Class in 20 minutes. 20 minutes. Big points. Big class. Bigger class. Big class. Okay. We are doing some challenging math before the test. Show up for practice and test questions. I'll be making some up for us to practice and prepare during class. Okay. This is a challenging chapter, chapter 12. Okay, we're good to go on the announcement. And let's save it. We're sending it. And Wes wants the car questions. There's the rent is due. Nervous about the exam? Oh, you'll be fine. It's just an exam. Where's the car quiz? Is it on the homework or the quiz, Wes? Oh, found it. Let's go take a look. I think that's the beep for the thing. Let's go look at the car question. Chapter 12, probability car question. Start 201, chapter 12, quiz, car question. Let's go do it. Here we go. A consumer organization estimates that over a 1-year period, 70% of cars will be repaired once, 5% will be repaired twice, and 3% will require 3 or more repairs. If you own 2 cars, what is the probability that? And let's take a look right here. Now, there's 2 versions of this question. We probably got enough time for the other one. But when you look at this, let's first write down the probabilities. So we're going to write down these probabilities right here. What is the probability that your car will need to be repaired once? Just tell me from looking at this. What is the probability that your car will need to be repaired once? So probability of 1 repair. 70%. Probability of 2 repairs is... probability of 3 or more repairs. What is the only thing missing on this list? Oh, what's the only thing missing on this list? To make this a sample space, it needs to have all the things that could occur. Probability of no repairs. What's probability of no repairs? Probability of no repairs is equal to what? Let's drive an Alpha. I drive a Peel P50. Honda CR-V. What is the probability of no repairs? And how would you find that? Well, the probability of repairs is equal to what is the probability of no repairs? What is the probability of no repairs? And how did I get the probability of repairs? Because either your car gets repaired 1 or 2 or 3 times. So the probability of no repairs is the what of getting repairs. What words would you use to describe these probabilities right here? These probabilities are what of each other? Because either your car gets repairs or does not get repairs. So we have the probability of no repairs right there, which is 0 repairs, or the probability of some repairs, which is 25%. They're complements. Great job right there, Evan. These are complements. So now it says you have 2 cars. So what is the probability that neither of your cars will need repairs? So your first car does not need repairs. So you have no repairs and no repairs. So your first car did not need repairs and your second car did not need repairs. What is the probability of not needing repairs and not needing repairs? So what will be the probability of your first car not needing? I think that's correct. Evan. Let's take a look right here. Evan is taking and doing 0.75 times 0.75. Whoops, I'm writing it right there. And I've already written it down there on the bottom with the notation, no repairs times no repairs. So if you follow along and do it this way right here, you can just take and multiply 0.75, which is the probability of no repairs, and your second car not needing... Oh, there it is. That should be it right there. Does that make sense? So that is the probability right there, Evan, not needing repairs and not needing repairs. Does that make sense? So there, Evan's updated the answer. I was like, it looked kind of correct, but nope, we got it. So there it is right there. Do not round. The probability that both your cars will need repairs. So what's the probability of both your cars needing repairs? So this would be needs repairs and need repairs. Oh yeah, don't divide by 2. So the probability in the second one is what's the probability your car needs repairs and needs repairs? So what's the probability of that? I think it's 6.25, is it? What's the probability of needs repairs, need repairs? Yep, that's it right there. Needs repairs, need repairs. So there we go. There's probably needs repairs. What's the probability that at least one of your cars will need repairs? So this is a really good tough one at the end right here. Now we actually need to do a complement. So if you have 2 cars, I know it's a huge assumption right here, Charlie, that your cars are independent. Like, because if one of your cars need repairs, you'll probably drive the other one more. Huge assumption. So that's huge for this question. But yeah, 0.0. Yes, correct. That is I think, Evan, you're solving correctly. I'm going to draw the sample space. So you could actually go through and solve this full sample space, but we want the probability of at least one of your cars needs repairs. What would be a really quick way to solve this? Because if you take these right here and add them, those will equal up to 1. So what is a really... Oh, we'll do the next one right here, Wes. I think we got more enough time to do yours. The other one of yours is like 1 car, I think. So now we want the probability of at least 1 car needs repairs. I mean, yes, kind of. I think you're on the right track. We want this probability right here, that one I've highlighted in yellow. And we don't want this probability down here. So how could we? Those would add up to 1. So, I didn't put the no repair, right? No wonder, that's my fault. Let's throw some points. Yeah, no, that's my fault. I got 3 big points for that. I made a notation error right there. It should be no repair down at the bottom. So 5,000 points. So it would be 1 minus the probability. So it's what is at least one of our cars need repairs? It would be... I'll write it right here for you. And this says everything but both of our cars not needing repairs. Does that make sense? It is either the case that neither of our cars need repairs, or at least one of our cars need repairs. But does that make sense right here? Who falls on this last one's the tough one, because we're solving for this probability. So we subtract this one off from 1 to get the remaining probability over here, because it's either the case that neither of our cars needed repairs, or at least one of our cars needed repairs. So 1 minus no repairs. So 1 and 3 will be complements of each other. Really good question right there, especially to solve. And you could just take this probability right here and do 1 minus. That's where you want to be careful, because you have to know how to solve those. There's a soda question that's really great on this. Exactly. 1 minus the probability of both cars not needing repairs. And here looks to be Wes's question. So let's take a note on this one. Car question 2, version 1 and 1.0803. Version 3. Or version 2 of this. Okay, let's do version 2 right here. A consumer car agency reports that 90% of cars will need repairs once a year, 10% twice, 4% 3 or more. So what's the first thing we're going to do? We're going to do this the exact same way. What are we going to do right here? We're going to write down the probabilities just like we did a moment ago. So make sure to be here and write the probabilities with us. Probability of 1 repair is equal to 19%. Probability of 2 repairs is equal to 10%. Probability of 3 repairs is equal to 4%. What is the probability of no repairs? Which is the first question. What is the probability of no repairs? And how would you find that? This deals with the sum of all probabilities equals to 1. Find the complement, exactly. Or you could just subtract from 1 or find complement, as Wes is pointing out. So this is a rule of probability that the set of all probabilities adds up to 1. So we can find the complement, and that should be 67% right there, because that's the missing and it's part of the set of all probabilities right there. So that would be the first answer right there. No more than 1 repair. No more than 1 repair can be described as what? So no more than 1 repair. No more than 1 repair. No more than 1 repair. So no more than 1 repair. It could get 1. Well, no more than. No more than would mean 1 or 0. Does that make sense? If I say there can be no more than 1 person in this room, then there can only be 1 or 0. Does that make sense? No more than 1, 1 or 0. At least some repairs. And it's really easy to see some repairs if you look at the first answer right there. What is the probability of some repairs? Correct, Wes, for that one. Yep. That's why I'm highlighting those. Great answers, Wes. Great job following along. Good practice. And some repairs would have the probability of what? Some repairs would have the probability of what? What would be the probability of some repairs? Careful. Oh, you're saying for the second one. That is correct, Evan. Yes. Great job, Evan, for the second one. Some repairs would be what? I've highlighted the way it looks. Some repairs are the way I've highlighted it right there. What's the probability of some repairs? Correct. Yep. And roll that other answer. No. There we go. Great job. 67, 86, 33. 67, 86, 33. I think it's got it. Did I put them all? Oh my god. What is wrong with me today? Let me look at it. 86. Oh my gosh. I should have looked. Oh my gosh. Oh my gosh. Careful writing those numbers. Careful writing those numbers. Careful writing those numbers right there. Can we do the high blood pressure one after class? Which one? What is the high blood pressure? We only got to 7 minutes right here. Oh my god. I gotta look at those answers. We're just seeing if you're following along. We're just seeing if you're practicing. Oh my gosh. Oh my gosh. We make all those decimal errors. We make all the decimal errors right here. Throw in more points. We'll try to do the high blood pressure. We will do the high blood pressure one after class. With that, we're going to head off right here, take a quick break, and get ready for some class, get some more sleep. 5 hours. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.